answer should look like something like this, right? Yeah, so we can look at it as or something. I'd be happy to do that. Yes.
Sorry.
Any other questions?
Yeah.
Yeah.
How would you, this may be something completely obvious, but it's blowing my mind right now. But how would you evaluate for X without defining a T value? Or do you set an arbitrary constant for T, or I doubt that that's the way to do it.
No. Okay, so here's our function that we're trying to evaluate, right?
Yeah.
After, I can't reach up that high. There we go. Okay. If I do this integration, T disappears because the limits take out T.
Okay.
And so you only set a function only of X after the integration. So you need to set up the function here, which has T and X in it.
Yeah.
Right? The T gets passed, right? That's what this needs to be a function of T for the integral. And then for the X, you have to go through a for loop, right? You solve for, what is it, X equal to -1 to 1. So you put in -1 in, and you solve. And you put it for -0.96.
So so for the full equation, it's only a function of X, but to define a function to then integrate, that would be a function of both T and X?
Yes.
Okay.
Yeah, this function has to, T and X has to have both of them. And then you would feed in, because that changed on that format. It always pops up like that. Okay. So yeah, that your function has to have both T and X as inputs. The T will be the variable that you integrate over. The X, you did the constant, right? Anytime you do the integral, you feed the X as a constant, and that's why we use a for loop in order to basically have a constant for X every time it is formed.
Okay.
Are you able to tell us what the interval should be equal to, or?
I can, well, it depends upon X, right? So I give you two answers.
Oh.
If it's -1, if X is -1, here's the answer, and if X is 1, here's the answer. So either side, and that should down it for you.
Okay.
Someone back here had a question. Yes.
For number 2, evaluate the integral for x equals 0.
Yeah.
Do you want the 2 pi, or 2 divided by pi in there as well? When you
Oh,
evaluate the integral?
I wasn't clear. Yes, I do. Yeah, but I can see now that if you don't have it, I'm going to have to accept it as correct, right? Because I wasn't clear. My intention was that yes, you would have the 2 over pi in there. Or 2 over square root of pi. That was my intention. But since the problem's not clear, I always try to, create it as easy as I can. Okay? Yeah, any other questions? Okay, let's go on to the next homework. This time we're going to, integrals. Fun, right? How about derivatives? Yeah, more fun. Okay. So let's look at ordinary differential equations. Now the good news is we don't have to solve them. MATLAB solves them, right? Yay, MATLAB. Now there are like a million methods in MATLAB for solving things. They have symbolic solvers, they have numeric solvers, they have numeric solvers to handle various kinds of cases because differential equations, when you're solving them numerically, you can run into problems with singularities, high slopes, etc. So I'm just doing one of them. That's what we'll do for this class. One way of numerically solving differential equations. If in the future you gotta solve them, That's where the help documentation is, right? If this doesn't work for you, you gotta figure out another way of doing it. But I wanted to get you started, know what can be done, and then it's just details for if it fails. Okay, so if there's a function, ODE stands for ordinary differential equation 23. I have no idea what the 23 is. Okay, there's another variant, ODE 45. Again, I don't know what those are, but the 23. Okay. So what's a first order differential equation? So we'll not solve a second order differential equation, only a first order differential equation. So here's 3 of them, right? dy dt equals t plus 1. Sometimes it's written y dot, right? That's a derivative equals t plus 1. It only has a first derivative, so it's a first order differential equations. dy dx is equal to y plus 5x squared plus y. First order differential equation. Even though it has a y in there, the derivative, right, is first order. Okay, so this is what we can solve. So let's do one. Well, my first example here was dy dt equals t plus 1. This one's actually pretty simple. I told you that we won't be solving differential equations, right? I lied. We'll do one, just to, see what happens because it's a simple one. Then I'll do an example with one that we won't solve, right? But if I wanted to solve it, I move the dt to the right side and I integrate both sides. I get y is equal to the integral. And I'm not going to use a constant because the way MATLAB does it is with numerically, so let's put from some initial condition t0 up to a time t. And my function is t plus 1. And if I solve this, the t turns into 1/2 t squared, the 1 turns into a t. Right, for the first limit, the second one minus the terms with the t naught. So I can solve this, and I say, yeah, I can solve differential equations, right? Pat myself on the back, and at least I can solve this one. It has a linear term, it has a quadratic term with respect to y, okay? But, this is nice, but I want to use MATLAB. So what would I do in MATLAB? Well, here's my function, but we need to set up a function for MATLAB to do so. So I'm going to set up a function and I need to solve for t plus 1. So what MATLAB is going to require is a function based upon y is really a function of t, right? And I could have y on the right-hand side. This one doesn't, okay? Y is not used, but I could. So it's going to feed in values of t and y, and we have to compute dy dt. Well, pretty simple. Dy dt is simply t plus 1. Okay, so here's my function. Give it a function that it can now evaluate. So here's what I will do. There are 3 lines here because here's my differential equation solver. I need to give it a function. I use that @ sign because I put it at the end of the file. Okay. Function 1. So there's my function all over, and it says, okay, I can solve this. But it needs to know a couple of things. One is, what range do you want to solve this? Okay, so we need to give it a range or time span. So I'll give it a time span. The way that this function wants it is with a matrix with 2 things in it, the start time and an end time. So I'm like, okay, that's what you want. That's what I give you, right? So let's say we want to solve from time equal to 0 to time t equals 5. That's 0 to 5, we'll plug it in right here. The other thing we need, differential equations need initial values. First order differential equations require 1 initial value. So it wants to know what is my initial value. And it's at this first time, so it does not have to be a 0. Okay, at this first time, what's my initial condition? Well, I'm putting in 0 as an initial condition. y is 0 and time t equals to 0. Okay, it's going to output two things, so I have to set up a matrix to get two things out of a function. Because it'll return one thing, but if I use a matrix, I can get more than one thing. Yay, matrices, right? So that's how MATLAB gets around this issue. So we have two things. One will be an array of times. The other will be an array of the value of y. So let me go to MATLAB. So here's what I did. Here's exactly what was up on the PowerPoint, right? T span equals 0 to 5, y0, 0. I solved the ordinary differential equation. And at the end of the file, I have my function. Function dy dt is equal to t plus 1. So if I run this section, I get some outputs. Yay! Right? And so what does this look like, right? The initial condition was y is 0 at time equal to 0. So it better be 0. It is. Right? And we had, because I could solve this one by hand, right? A quadratic term and a linear term. So it increases, quadratically and linearly. I can't tell, but it does. It's consistent with that, right? So I'm good, right? If it went up and down and up and down and up and down, I'd say, hey, wait a second, something went wrong, right? But this is consistent with a quadratic and a linear term. So I'm like, yay, right? Yes?
Can you go back to the page where you showed the t-span and also the function?
This one? Or,
Well, how about the MATLAB file?
okay. So I have this here, the functions have to go at the end of the file because that's what MATLAB requires, right? Which is a little bit of a pain. Yeah, so they're not both in the same place. Okay? So that way I can solve a first order differential equation. Let's do one that's a little bit more difficult. So this time, this is harder to solve. And if I look at this, right, if I say, oh, I'll move dx to the right side and solve this, I'm like, oh man, that doesn't work, right? This is a lot more difficult to solve. So this is where I'm very happy to have MATLAB because I cannot solve this just off the top of my head, right? The other one, that one's easy. This one, no, not so easy, right? Okay. This one, I have my dy dx, which is what my function will have to return, okay? Is equal to y plus 5x squared plus 7, right? I changed t's to x's. So instead of time, it's now distance, but I can still solve the same thing, right? Whether the variable is x or t or smiley face, what does it matter, right? You can solve it. So let's use MATLAB. We'll do the same procedure. First, we need a function, right? So we need y dot, right? That's our dy dt is equal to this function, and it's a function of x and y. I have to go in this order. Okay, I better point this out. Have to go in this order, x, y. If I go in the other order, MATLAB won't know it. But if I go y, comma x, I have trouble. So x, comma y. So y dot is equal to y plus 5 times x squared plus 7. So I have y in here, I have x in here. It'll solve this if I, and there we go, right? And so we use both x and y. A little bit more difficult of a problem. Okay. When we solve it, I wrote things as x and x0 for initial condition. we return x and y, and that's our output. I call this function 2 so that I have a second function, right? Same script file, but I needed different function name. X span goes from 0 to 5, and initial condition is 0. X 0 is 0. So here's my function 2, exactly what I wrote in the PowerPoint, right? I actually copied and pasted, so they're identical. And if I go here, what's not identical, right, is it says figure 2 and it says plot x comma y. That's how I'm getting the plots, right? ODE did not generate the plot, ODE gave me x and y. And then I'm like, well, but I like to plot it. That's what I really want to see, right? So then I plotted it. So let's run this one. If I run this one, I get this function, right? Again, my initial condition was 0, so at time is 0, I get 0, and it increases, right? Honestly, I could not have told you what was going to happen because I hadn't solved it, right? But looks good, right? And I'm like, yay, MATLAB! Okay, so these are fun. Yes?
This is not related to that, but it's a different MATLAB question.
Yeah.
If I wanted to know a specific point at some x value, and I wanted it shown on the actual graph, how would I do that? Like, I want to show a dot at some point.
Yes, yes. So question is, how can I see a value on this plot, right? If I hover my cursor, there we go. The cursor is sitting there, right? It's not showing it. If I click on it, and I click on that point, it shows me the x and y value there. Okay, so I can click on points and it'll show me. Is that okay? All right, these were the easy ones. Now I'm going to do a hard one, a tricky one, right? All right, what if,
Whoa.
right, I'm going to trick you in two ways here, right? One, I'm not going to use y, I'm going to use theta. Oh no, right, different sign. Okay, so that's my first trick, right? My second trick is, this is a second order differential equation. That's a much more major trick, right? Yeah, so this is a tricky one. So what are we going to do? Well, this is a pendulum. So if I had a pendulum, you know, string hanging from up there with a mass and let it swing back and forth, that's a pendulum. And the G over L can be related to the resonant frequency, how fast it goes back and forth, okay? But the angle that it's at, right, is a function of time, right? I pull it, and then I let go and let it swing, right? Initially it has a certain theta. Theta goes to 0, went straight up and down, theta goes back up again, right? Negative, right? And goes back and forth. So theta is a function of time. Described by this function right here. Right? Want to know where it comes from? Check a physics book, right? I'm just giving it to you. L is the length, right? How long it is. Notice the mass never shows up. Pretty amazing thing. And so if I wanted to solve this, I can use MATLAB, but I have to use some tricks, right? And your homework, I'm going to make you do a second order differential equation, so you gotta know this trick. Okay? Yeah, question? No? Okay. So here's my trick, right? I have this problem. I can't put it in there. So what I am going to do is take my second order differential equation and make two first order differential equations. How do I do that? Let's use z, right? Z's not used here. So and I have two equations, so let's get z1 and z2. So z1 will be a function of time, and I'll just let it be theta. So you might say that's what we're solving for, z1. C2, I'm going to make d theta dt. Right? Well, we're going to set up matrices because everything in MATLAB is a matrix. So I only need C1, C2, but how did we solve things before? We solved it by finding y dot. So let's find C dot. So I need C dot, but I needed a C1 dot and C2 dot. So this is dC1 dt, dC2 dt. Okay? So what are they? Oh, dC2 dt. Sorry, let's start with the first one. dC1 dt, right? C1 dot. I take this, I take the derivative. It's not theta, it's now theta dot. All right, so I need to put theta dot in here, but I don't want to solve things in terms of theta. That's what I'm trying to get away from, right? I'm transforming it into z's. Well, what's theta dot? Z2. So Z1 dot is really Z2. That's what we have, right? Now Z2 dot, right? I put dot on here, this is now theta dot dot, which is up there. You say, yay, here's our function, right? So it plugs in there, minus g over L, that's pretty simple, sine, simple, and then I have theta, and I say, oh no, theta, but I'm turning everything into z's. Theta is C1. So make that a Z1.
Mm-hmm.
So it's actually very simple, and yet really complicated if I send you off to do it on your own. Yeah. Right? Okay, so let's go through it one more time. I promised you that it's showing up on your homework, so let's do it one more time. Okay, so I have a function, right? That's a second derivative equals a bunch of other stuff. And it's theta, but if it were y, it would be a y double dot is equal to some function of t and y. Okay? So we have theta, it's double dot, but I can only work with one derivative. So we're going to create a new thing, and I'm using c, and I'll make z is equal to my y, or theta. But that's my first one, so z1. z2 should be the next derivative. So guess what? If I had a third order differential equation, I'd throw z3 is equal to theta double dot.
Mm-hmm.
If I had a fourth order differential equation, let's say that z4 is equal to theta to the triple dot.
Yeah.
Right? Let's just, right? Just expand that out. This is the key right here. This line. Then MATLAB wants C dot. So I need to find C dot. Well, C dot, we now have two equations, so just turn into a matrix. Oh, it's sad, but it's a matrix. So C dot is C1 dot and C2 dot. And you say, well, what is Z1 dot? But I cannot use theta anymore. Okay, so Z1, it's here, Z1 dot must be theta dot. Which is sitting here, so it's just Z2. Z2 dot has to be theta dot dot. And I don't see theta dot dot here, but I see it up there. Like, aha. And now I'm super excited and start copying everything over, minus g over L, sine, and I run into that theta, I'm like, uh-oh. I'm trying to get rid of theta. So now I'm like, how do I get rid of theta, right? I got sine, and I say, well, what can I do? Oh, theta, it's C1. So now I got this, I put C1 in for the theta. So it's not sine theta, it's sine C1.
Mm-hmm.
Any questions? These notes will be on Blackboard, okay? Yes,
Say you had third order differential equation, would
Yeah.
it just be that C3 dot would equal C4, and so on?
so Z2 dot would be equal to Z3.
C3 and first.
Yeah, and then Z3 dot would be your function.
So your function goes to the last.
Yeah, or move down. Yep, yes. Isn't that an amazing trick? Yeah. Okay, another place this shows up a lot is when solving physics problem where you have position, acceleration, velocity. Right? Well, we've been talking about position, velocity, acceleration. Yep. Okay. So now we get into the tricky parts with MATLAB, right? Because I have to implement my z dot, right? I'm given it the function named pendulum. I have to return z dot given t and c. But I have two equations, so we're going to have matrix with everything embedded into these matrices. T is simple, and it's a scalar. Yay, okay. C, right, has two things in it, right, C1 and C2.
Mm-hmm.
So that's going to feed in values of C1 and C2. And then on the right-hand side here, we can solve for Z dot. So I put it here, Z dot 1, right, it's just C of 2, the second elementary rate for C. That's what we have up there, C1 dot is equal to C2. Okay. Z dot 2, right, because we have to find Z dot 2 or C2 dot. Maybe I should have said C1 dot and C2 dot. Is equal to minus G over L times sine of C of 1. Right? But because I'm getting C as a matrix, right, I have to pull the first element out of that matrix, C. So it's C1. Yes?
How does it know what C is for to define that?
Well, it doesn't, right? What MATLAB is doing is throwing values of T in and C in and trying to compute what the derivative is. And so it just gives you values, right? It doesn't actually know, right? It's making a guess. It knows T, right? Just saying, all right, this time, what's happening? I don't know my values of Z, but based upon what I saw before, I'm guessing that it's this. Plug some values in. Is everything consistent? Yes, it's happening. No, it has to recompute again and make some more guesses. Okay, and so those guesses and trying to figure out what it is, right, is the magic behind the algorithm. And we're like, yay, MATLAB! I'm glad I don't have to implement that function. Okay. So it doesn't always guess properly. I mean, given these values, I can always find a C1 dot and C2 dot, but that doesn't mean that it's going to be consistent with the initial conditions and everything. So it has to work that out. Yes?
Why is the length the same as gravity? Why are they equal to each other? Just out of curiosity.
Just to get the number 1.
Okay.
Right? They're totally up to me, right? I said
Okay.
it is 1, and I'm like, I'll make the number 1.
Okay.
That sounds nice and convenient.
Okay,
right?
yeah.
So, yeah. I'll
Okay.
make the link.
That sounds good.
Yeah. Right, when I took physics, I guess many years ago, right, my physics professor said that in physics there are only 3 answers: 0, 1, and infinity.
Mm-hmm.
Right? So I made sure that the answer was right. Okay.
Mm.
Okay, so I got C dot 1, I got C dot 2, but I have to return the matrix. And first row, right, has to be C1 dot, right? and the second row has to be Z2 dot, so I use a semicolon to break up the
Mm-hmm.
rows.
Mm-hmm.
Okay. Here's my function. So I have to come in, down, write a column here, and work out a return the column. Okay, a little bit more complicated, definitely. Yes,
At the middle, C.1 was C2,
yes.
what does 2 represent?
Is that what?
What the 2, what does 2 represent?
Because of over here, I can't reach high enough, but Z1 dot is equal to Z2.
So, like that, like this.
Okay, yes.
That's not just a label though, is it? Actually,
No, it's not labeled. It's the second element, but Z is coming in, so Z has on it, don't have any chalk. Has Z1 and Z2 as a matrix. And so when I say Z of 1, it's the first thing. When I say Z of 2, it's the second thing. And that's why I had to say Z of 2 or Z of 1. If I just put Z in here, I'm getting a matrix,
Yeah.
right? Not Z1 or not Z2. If it was a 2 by 2, I'd have to give it row column. Okay, so now we have a function, right? More complicated, but we have a function. Now let's solve it. We're just spent from 0 to 10 seconds, right? With 1 for the geometry. Now it'll have a cycle of about 2 pi radians of degrees. Initial conditions. I put 1 and 0, right? I actually have to have 2 initial conditions. It's now,
T and Z.
well, a second order differential equation is 2 initial conditions, but we turn into 2 first order differential equations. So each differential equation needs an initial condition. I have another slide on the initial conditions, so let's come back to that. Our output is coming in 2 places. We're going to get an output for Z1 and an output for Z2. So what's really weird is T is a matrix. Z is another matrix. All within this matrix. Crazy. But that's how MATLAB handles it. I give it the function name was pendulum. I give it the time span, that stayed the same. Yay, something that didn't change like crazy, right? Start getting into time. 0 and 10. And Z0 are initial conditions, but it's a matrix. So let's start with our initial conditions, right? I'm specifying it here. I have to give it initial conditions for Z1 and Z2. So if I set Z1 as 1, Z2 is 0, right? Let's figure out what I'm saying here, right? Mathematically, Z1 at 0 is beta, right? That should be at 0, sorry. It's time, but it should be beta to 0. Beta at 0 is set to 1. So it's saying the initial angle is 1 radian, which is 57 degrees, okay? But this is all set up for radians. So initial angle, 1 radian. C2 was beta dot. Beta dot is not the angle, it's the derivative of the angle. So it's the angular velocity. So radians per second, and so initially it's 0 radians per second. So it's like I took this pendulum, I picked it up, it's sitting right here at 57 degrees, 1 radian, and that's the angle, with no velocity, and I let go. That's the simulation. If I had it here and I give it a push, I'd have to change this value. If I lifted it up a different distance, I would have changed this value. And so I give it, this column, right? First row, second row, so I use a semicolon. It's plugging into here. So that's how it's getting Z1 and Z2, right? So there's my initial conditions. The output, right? I kept this here so we can remember Z1 and Z2, right? Angular velocity. My output, C, they changed things on us. I had to input Z1 on the first row, Z2 on the second row. Coming out, Z1 is the first column, and Z2 is the second column. It's like, oh man, why'd they do that, right? They did it so that the
Multiply.
number of columns here matches T if it's number of columns. And so they needed to get the matrices to match up in size to return it all in one big matrix. Yeah. Okay? So that's what we have. We have Z1 and Z2 coming back to us in columns. Well, my goal was to get theta, right? So what is theta? Theta is C1. So it's the first column out of my output. Turns out, at the same time, because we had to turn it into two equations, we get the angular velocity is Z2, right? We get it for free. We didn't ask for it, right? Except I guess we did, right, after we transformed things. So we got it. So here's theta, right? Switch it to our second order differential equation. But we also got the angular velocity. So if I want to write a couple of statements, theta and velocity, I take C, right? Because here's my matrix. And here's a trick in MATLAB, right? So I need row, comma, column, that row, column. So I need a row, column. If I want a single number, let's say like 1, comma 1, row 1, column 1. But I want everything in this row, right? I want this, everything in this column. So I want every row but column 1. Okay, that's what C1 should be. Every row but column 1. So if I come up here, I put a colon in, right? A colon means all. And that has this neat thing, right? So this is very handy. So now everything out of every row, but only column 1 will be theta. So now C1 just turned into theta, right? I extracted out of C, right? I extracted the first column. And for velocity, I need the second column out of C. So I give it colon, comma, 2. Yes?
Why would it just say one work?
Why is what?
Why couldn't you just put theta to C1?
C1, because it's a 2D matrix. It will not know which, do you want the row, do you want the column, it won't know what you're asking for. So you can't just say Z of 1 because it doesn't know if you want the first row or the first column. Right? A two-dimensional matrix, you have to give both row and column. When it's one-dimensional, if you say Z2, it doesn't matter if it's row, it finds the second thing, and if it's a column, it finds the second one down. Because it's smart enough to just kind of figure out what you want. But here, it's a 2D, right? C1 has a bunch of entries in it going this way, so it's a 2D matrix.
And if we wanted to do all the columns but one row, we would just flip it around.
Yes, yep, yeah, works great, yes it does. Any other questions? No? Okay, so let's go over to MATLAB. So what does MATLAB do, right? Here's our third example. I have t spanning from 0 to 10. I have z naught. It's 1 and 0, right? It starts at a 1 radian with 0 velocity, angular velocity. I give it my function, right? The ODE23 telling it to use pendulum as the function. I get theta, I get velocity, and I will plot theta. Okay. And then, because I like to have fun, right? I will also plot the velocity, and I will put some labels on there. Woohoo! Okay. And if I come down here, here's my function pendulum, right? I put G in, I put L in, right? Both 9.8. Z dot 1 was Z2. This is identical to what we had before. We get our two values out of Z dot for our matrix coming out of this function. And then I execute the code. And I get this lovely plot. And I'm like, yay, right? Okay, so time is on the x-axis. I went from 0 to 10 seconds. Starting at time 0, my initial conditions were 0 velocity, that's the red line. 1 radian for the angle, that's the blue line. It's like, good, right? And then what happens with the pendulum? The folds down, right? So sometime later, we get to 0 angle. Now we get to negative angle, right? And it started out here, it went down, and it swung up to the other side. So negative 1 radians. And then it goes back and it goes through the 0 points again and gets to a starting point at just over 6, 2 pi. So 2 pi radians, and it started here, went down to the other side, and back. Okay. And repeat. The velocity starts at 0. When it goes to the point 0, when it's vertical, it has its maximum speed. And it's a negative sign, that's this direction. Comes back up, when it goes to the 0 points again, it's at the maximum speed on the other side, right? Positive number. Because first time it was swinging this way, next time it was swinging this way. And so that's the summation of a pendulum. Okay, so your homework is going to be, I have 2 problems on your homework. That's not homework. 6. One is, we'll solve dy dx is equal to cosine of t. You'll be like, yay, that looks pretty simple. In fact, I can kind of guess what the answer is going to be. Okay, it should be a sign. Okay, okay. But, so if you don't get a sign, you're like, uh-oh, what went wrong? Okay. Okay, so I figured we'd start with something where you know the answer so you can see things, right? Don't just plot a sign. If you don't use the ODE23 function, it's wrong, okay? Even though you can do it by hand, I want you to use MATLAB. Okay, it says use MATLAB, right? You have to use ODE23. Okay, second one, this is the tricky one, right? I tried to not be as tricky as the pendulum, right? I didn't use theta, I used y. Right, so it took away that trick, right? But it's still a second order differential equation. So if you break it into 2 first order differential equations, now you can use the code to evaluate it and plot what you get. Okay, so that's your homework. So for what you submit, right, you need a script file, publish it so that I can see everything and say, wow, that's so pretty, right? If you use the .imp function, give it to me, right? If you didn't, that's fine too, right? There's 3 ways of making functions, you don't have to, but if you didn't, give it to me, right? And tell me what z dot is, right? Come up with your z1 dot, z2 dot, show me what that is. Okay, do it on paper, you don't need to type it up, I don't care. So what I'm asking for, just 1 second, what I'm asking for is like this up here, right? Come up, show me what you came up with. That way I know your work. So yes, there's actually a hand calculation on the second problem. It's like, oh no, I thought this was a MATLAB course and I'm making it to a hand calculation. Yes, I am that evil, right? But I think you can handle it, okay? Okay, so questions? Anything? Okay, officially time is up, it's 50, so you're welcome to leave.